Well, hello and welcome. My name is Carlos Sanchez. I'm that guy on the screen, Senior Director of Operational Technology for Fortinet. Uh, Today, we're going to talk about a couple of things that are pertaining, really important for us in terms of what we do in operational technology and how we protect our structures. Interestingly enough, you will think that some of these large multinationals, all these companies, they have really complex, highly tiered networks. And if you think that, you will be wrong. The flat network is here to stay. And unfortunately, it's up to us as security professionals and practitioners to bring some level of, sanity into these structures that ultimately can have the worst thing that can happen, right, in terms of safety. Somebody lose their life because the safety system is not being properly isolated. So I will give you a story that happened to me in one of those highly controlled areas. I got called in to do an audit, a security audit, and usually what we do is we plug in, or depending on the location, right, and we try to see what we can access. What can we access from a given point? I'm usually looking for some type of VLAN structure, some routing, something that we can see that there is at least some level of isolation between what we call the critical areas into the MWR, which that's an acronym for morale, welfare, and recreation. All those areas. From my room in that installation, I can hit PLCs. Located on the other side of the generation area, that generation area actually supported some drilling operations. Not absolutely everything there was considered critical, and we were able to do that. So yeah, even in those instances, yeah, there is no segmentation whatsoever. There is a special need now for segmentation, something that we need to do. Because if we look at it, all you're doing with segmentation, and later on we're going to talk about micro-segmentation, and believe it or not, if you are been around long enough to remember the 7-layer OSI model, I call it the 8-layer sometimes, if you remember that, that is the foundation for proper segmentation. Because we start from layer 1 all the way to layer 7 and layer 8. And I'll tell you what layer 8 is at one point, because everybody says, it's only 7. No, there's one more. Anyway, so that's what we're doing. Our recommendation is use segmentation, micro-segmentation, and layer 7 segmentation as a proactive approach to mitigate a threat. Once a threat enters an environment, trust me, I always say it's easier for me to take on one person here to take on all of you at the same time. And that is the concept behind micro-segmentation. Make your areas of responsibility smaller. You can create more granular policies. You have more visibility of the traffic that is there, and you can create some more, let's say, more comprehensive security treatments for the data that is traversing that environment from one to the other. So what do we segment? The first thing, notice that I put company personnel in there, because frankly, the majority of threats that happen in our environments come from the inside, and come from the idea that we trust everybody that is on this side of the door. Well, we know that that's not probably the most proper way to address security, trusting everybody. And probably during these conversations, you're going to hear about the concept of zero trust architecture, zero trust network architecture. Yeah, that is important. But in terms of what we do in operational technology, we're going to focus on remote access, third-party access, and of course, the physical segmentation that is done, creating some division between the traditional IT and OT, and doing some inspection from east to west, left to right, north to south. And when we get to this point here, God, the pointer works. That's when we're going to start talking a little bit more detail about the OSI model. By the way, I can give you the presentation at the end, so if you want to take the picture, that's fine, but presentation will be available to you. So yeah, there are several models in the industry. By the way, everybody here from OT, right? Everybody here, it's come from the industrial side. I'm old school. I still call it industrial security. I don't call it OT, but people that work in industrial or critical infrastructure. But yeah, there are several models, and we're going to make reference to those. You're not going to walk out of here being an expert in IEC 62443 or the Purdue model. Frankly, if you tier your network using one of those architecture models, reference models, good to go, good to go. If you don't, and you use a hybrid of those, take the best elements of those reference architectures or those models and use it in your environment, more power to you. The only thing that matters here is that it has to make sense to the business, to your business. You know your business better, your line of business better than IEC and the Purdue folks. So you can take these concepts, which, by the way, when you think about it, we've been segmenting networks since the 90s. Because if we look at VLANs and segmenting everything via VLAN, we've been doing this since the 90s. We've been separating functions since the 90s. Now, on the industrial side, that was untouchable. But now we know that the industrial side is as exposed or as as vulnerable as other parts of the IT. In fact, even more, because most people think that it's not going to happen to them. So yeah, nobody in this room thinks like a bad guy. Probably me and that guy over there in the back. But other than that, we always establish protections protocols in our environments from the standpoint that we're good people and everybody is good and we're never going to get hit. Show of hands, how many of you guys have seen a hack happening? Not the effects, not what happens after. The hack actually happening. Let me tell you, I've seen several, and in some of the instances, the variations and the change of data structures and the change of procedures are so slight that unless you know what you're looking at, you will never see it, but you will see the effects. When we talk about network segmentation, again, what we're trying to do is, if you don't remember anything that I say today, remember that is make it smaller so you have better visibility and control of that area. So yeah, a firewall alone, that doesn't work. Frankly, the firewalls, I mean, when we throw around the term next generation firewall, honestly, that's been around since 2008, 2009. I mean, we should be talking in terms of, secure, next generation security devices, which is what we actually recommend calling it. But a firewall alone, that you haven't done your due diligence and looking and analyzing traffic patterns, you're wasting your time. It can be bypassed. Control systems. It's interesting because if you ask most modern thinkers in security, they believe that because these are typically old systems, they're never going to get hacked. Nothing can be farther from the truth. Because frankly, for us, especially, I work offensive for some time, it's really easy. Antivirus definitions only go back to 2012. From about 10 years, that's all they go. All I got to do is look for an attack from like 1995, 1996, and you're in. If you ask, a bunch of the younger guys, hey, how do you modify a master boot record of a computer? And they're going to go, master boot what? Okay, so that, just to give you an idea, things that can be modified and easy to recycle those attacks. So yeah, defensing that, we're going back to that OSI model, 7-layer model, like 8-layer model really, but we're going to go into that because in order to get us to get there, disclaimer and an editorial comment, you're not going to get there from day one. It's going to take some time to get to that level of granularity. However, the ultimate goal is for us to have visibility on every single bit and piece of information that goes across your network and be able to control it. So yeah, we all been in IT. Before OT existed, IT was the thing. Some people don't even recognize OT. But when we're looking at the knowledge that we have acquired from OT, as practitioners and as a company, we have taken the technologies that we developed within Fortinet, we have adapted those technologies to the operational technology environment, and the same thing goes with the best practices and the concepts that we learn in IT. Segmentation didn't start in OT. Trust me, let's call it what it is. This is something that's been around for quite some time. Understand industrial automation control systems, for sure, that is important because when we try to implement or make changes in the production environment, the first thing that your superintendent, your plant manager, the main engineer is going to ask you is this going to break the production? Because remember, IT is a service to the business, OT is the business. So we're talking here that whatever happens in OT is directly correlated to the production on the bottom line. What IT is still a support mechanism. It's a cost center, it's not a revenue center. So yeah, what we do in that side is directly correlated to revenue. So yeah, those technologies that we have, SIM, SIM, login, syslog, all those things, NAC that were born in IT, they do have a place in OT. And utilize those same concepts to profile the network and devices that can lead you to that microsegmentation path. So there you go, flat network. Flat network, one single subnet. Everybody has the same IP. You might even, in OT, we don't have DHCP that often, but you might even have a DHCP server there. You go ahead, plug in your laptop, get an IP. If you know what you're looking for, or even if you're malicious, because you don't even have to need information. All I got to do is do the denial of service attack and just pollute the whole segment, and there you go. Because it's really easy. You can do that from one laptop. Yeah, you don't need that much. However, everything here is exposed. The guy from the guy at the guard shack can get to the SCADA historian. Is that good? I'm not going to say it's good. Maybe the guy from the guard shack is the guy that can configure SCADA. Doubtful. But anyway, even if he is the guy, well, then probably that structure works. If all you have is one historian, one PLC, and a couple of stations and probably one HMI, they got 3 there, but only one. Hey, you probably don't need to segment. However, the reality is that as we see all these big installations, energy, transportation, manufacturing, all you see in some instances is a gigantic flat network. We get called in all the time, and our discussion is, where does the IT stop? Where is OT start? And the answer is, we don't. They just want one single network. That alone, I mean, is reason for concern. Because yeah, I mean, maybe malicious or not, I mean, you're exposed, everything is open and exposed. The next level of segmentation, and the one that we're all familiar with, is VLANs. Layer 2, 802.1q trunking. I'll give you the slide, don't worry about it. But if you're gonna take a picture, let me know so I can post. Anyway, well, yeah, layer 2, 802.1q, this has been around for around 10 days. In the 90s, we were doing VLANs. And again, depending on your line of business, this might be sufficient to separate IT from OT, left to right, up and down. So you can do that. There's not, notice that I'm not gonna say at any point, if you're not doing this, you're doing it wrong. There might be a business reason for you doing it the way you're doing. The only thing is that at this point, now, if this PLC here on VLAN C, they get whacked, these two don't suffer. You can put some level of mitigation. Although in this case, the way to stop it might be just to, shut down that VLAN. Might be that, maybe you have some automated way of doing it. However, at this point, we're getting a little bit closer to the model that where we want to be, which is having visibility, total visibility control, so we can have situational awareness and get some actionable intelligence depending on the data that we receive. Layer 3 segmentation, right? Layer 3 is kind of funny because a lot of people forget networks. I mean, one of the first methods that we use for segmentation, in addition to VLANs, was putting a bunch of different subnets. One number here, one number here. We get a router to route in between them, and then we can put an access list that says that this guy can get to this guy. Very simple. It's there. Just about any single security device supports that. Again, your business might say, this is all I need. Now, when we start looking at those architecture models that I mentioned, like the Purdue model, ISA 99, IEC 62443, if we look at those models fundamentally, they're doing exactly what we talked about in terms of tiering the network based on function. Define secure zones and define secure conduits. A zone, a series of like devices that share one level of security is sharing between them. A conduit, it can be nothing but a wire, but it might be a secure connection in between two zones. That connection might be, you might connect it over the WAN for all that matters, or you can have it in the same spot, you can have it in the same network, and you go from one side to the other, and you determine one goes from east to west. However, if we contrast those three models, I62443, ISA 99, and the Purdue model, 443 is really well detailed, and it has all the security levels assigned, that if you're looking for something that is more prescriptive in terms of security in the OT environment, I'm not advocating for anything, but I say 443 is a little bit farther ahead than the other ones. because it's written and it has a lot of contributors, so it continues to expand. All these models, they are based on, and you're going to hear me harp about that, visibility, control, and situational awareness. So you have to have visibility. You have to see what's going into your network, who's coming in order to give it a security treatment. What are you going to do with that? Am I going to allow it? I'm going to deny it. I'm going to say that this device has access to this other device. But if I don't see the traffic and look at everything only from the network perspective, meaning from the number, IP only, yeah, you can do it. However, you're missing a lot of information. And that missing a lot of information might turn into something really ugly. And this is just a zone model. And when we talk about the zones, is all these devices on this zone and this zone, they all share a series of common parameters, and you apply a security treatment depending on what they do. Firewall in between all of them, and then of course the enterprise zone. Sometimes, I mean, this doesn't exist, and they go from one to the other. It depends on the business line. However, the one thing that this gives us is the ability to say that this guy has a series of security parameters that are totally different from this one. When we talk about conduits, those are that's secure transfer. It might be nothing but a wire for what matters. I know it sounds kind of cool. I mean, conduit, it sounds like a really snazzy word. But really, here, you start doing some level of examination, and then you'll determine what goes here, and the level of security in between all of them is going to be conduit-based. The conduit might be a VLAN. If we want to get very technical about it, it might be a wire, it might be a VLAN, it might be anything of that nature. So now this is the way we do it in Fortinet. Now we go all out. Alphabet soup, a hell of a thing to follow. However, the idea behind this is the granularity that exists in creating the redundancies in the entire model. If you look at here, on this side, you see on the right side, 5 different levels. Those 5 different levels, I mean, coincide or correspond with IEC 62443. From the control side, when you have your PLCs, RTUs, and even some HMIs at that level. Supervisory, when you start seeing the first level of control, SCADA control. And then as you move up, the DMZ or the division between IT and OT, and then the resources that we have in OT. In the good old days, this can exist without this. In the good old days. Now it's different, because the data that we collect from the devices down here will directly affect the bottom line, and they have to be moved securely, instantly. And in some instances, and this is one thing, oh yeah, we do have it. In some instances, your SCADA, and a lot of people are doing this now, by the way, they're putting SCADA historians or a replica SCADA historian in the cloud. 5, 6 years ago, you would have said, hey, put a historian on the cloud. They would have run you out of the room with pitchforks and torches and all that. Now it's an alternative. And in fact, there are companies, I believe one of the sponsors here, that they have a really interesting strategy around SCADA on the cloud, or a cloud SCADA instance. So this is, whether we like it or not, it's happening. I'm going to skip this one. All right. You heard me talk about visibility, control, and awareness. When we start, the ones that I really care about are these two, because these are OSI dependent. These two, visibility and control. Why are they OSI dependent? The first level of visibility, when you start profiling devices, you got to do it in between layer 1 and layer 2, and you got to do it passively in order to make it efficient. You go past layer 2, past level 2 OSI or layer 2 OSI, when you're profiling devices, at that point you need to rely on DHCP or a source of IP to see what device is and fingerprint them and create a model. Well, that really doesn't work, because if you are onboarding devices and you got to wait till it gets to level 3 of OSI before you can recognize them, you're a little bit too late at that point. And by the way, what I'm talking about here is, and this is what will make your day or break it, is you can do segmentation, you can do micro-segmentation, but if you got to have hands-on equipment all the time, that creates, basically you're doing busy work. What we're going to talk about here at the end is do all this stuff automagically. It's going to be presenting the model and let this happen on its own. So the next time that you onboard a device, you already have the profiles created, and it says, all right, when a PLC from manufacturer X or Y comes in, I'm going to move it to this VLAN. This VLAN upstream is going to have a security treatment that is going to look at the traffic that I'm expected to see from that device, and everything else I can quarantine, I can block, and I can do something with it. It depends on what your business rules are. Another one of those models. Oh, look at that. Commercial. We have a line of rugged next generation firewall devices, some with 3G, 4G. And later on, I'm going to be talking a little bit about this guy, the FortiDeceptor. That is one of the products that we put on our line that actually do deep, not only do, it's a honeypot, but it also has a visibility component that is visibility and visualization component, which is really interesting, which will help you. It will take you to that to that place where you want to be in terms of having the visibility to create models and secure and create smaller collision domains. Now let's go to layer 7. We went through. We're going to skip from layer 3. We go straight to layer 7 because everything that happens in between the session, presentation, transport, and all those layers, really they're irrelevant to us in terms of practitioners in creating that segmentation model. Now, when we go to layer 7, we have to be application aware. Yeah, you can do this if you know the TCP port. You can do the TCP port and create access lists till you're blue in the face. Is that efficient? Nah. Let's do it a little bit easier. I'm gonna within an operating system, Fortinet, by the way, we have the ability to recognize, natively, applications that are specific to OT. Let me take one for instance, one that is near and dear to all of us, Modbus. It's been around since I believe it was in 1982 that Modbus came around. It was started life as a serial protocol, and it has evolved all the way to what it is now. And in fact, the next iteration of Modbus is going to have SSL built in it. But we don't care much about that. The idea is here that now when I see Modbus coming from one part of the network, I can give it a security treatment right away. Oops, I killed it. There you go. So now, and again, all this is done passively. You don't want to have an agent in all these things. You want to do it passively because it make it a lot quicker. But at this point, the device, recognizes this being a Modbus transaction. I give it when I see that it's a Modbus transaction, then I can say, I can do one or two things. You can go really light at layer 7 and say, I'm only going to allow Modbus from this side, from this set of PLCs to my historian, to my industrial control systems. Or I can say something a little bit more comprehensive and detailed, and I say, God damn it, sorry. Keep pressing the wrong button. I can say something like, if I see this string of registers, I am going to allow it, or I'm going to deny it. By the way, that's 01010101010101. Anybody here work for Schneider? Okay, good. That's 01010101. This was a CVE that came in 2016, that if you put that into a Schneider PLC, it'll send it back to factory default. So now, if you guys been around for quite some time, what else is 0101010101 in a row? That's alarm indicator and signal in most systems. It comes as a 01000101, and then a break code at the end. So if this was in your network at some point, and you had Schneider PLCs and you broadcast them out, they'll all go back to factory default. Cool thing. Not really. This was actually, by the way, this was an actual capture for real. This is not me joking about. This was for real. A colleague of mine had an issue that they will put PLCs. Nobody uses DHCP on a plant. Nobody does. You go ahead and you hard code everything. You put the static IP and you go and install it. Well, these cats will go get the PLCs, they configure, and they go put them in operation. They try to add them to the historian, and they go back to factory default. And everybody's going like, man, what the hell's going on? Lo and behold, a young guy put a script in one of an SCADA historian. And guess what string that script was sending out? 0101010108. So once they found it, they told me, hey, if you don't mind, I'm going to step outside. We're going to have a chat with this guy. So I figured that was a career limiting move for the guy. Unfortunately, that does happen. Was it malicious? I don't think that is malicious. Yes, sir. I do mind, but that's fine. I'll go. No. Drop the mic, I'm out. All right, which one? This one works? Let's go with that. I feel like I should be saying, today we figure out how to kill Superman. Anyway. So here we are. So that happened for real. In this case, can you see me? In this case, since we're at layer 7 already, now we can make some really granular decisions as to what happens next. Within our OS, we have the ability to have that, not only have the visibility and do the packet inspection, but we can also do the visualization of those devices as they are added to the network. That is really important. In terms of the NOC and SOC, when they can see what's going on, as you start adding devices and see where they're at, this is really important. However, for me, being the OT guy that I am, what I really care about is where are those devices relative to some architecture model. In this case, it's relative to the Purdue model as they are added. So part of it is it already did the segmentation, the initial part, because that firewall is aware that it's talking to the industrial side of the house. Makes it a little bit easier because if you start looking at the tiering and dividing IT from OT, is doing half your job already because it created the division, is aware that it's talking to OT devices, and it creates all the logical connections and visualization and accordingly. However, but wait, there's more. Is that enough? Is that enough to segment your network? It could be, but what we're looking at now is the wash, rinse, and repeat. What we want is when you already created the security policies, you have the security policies, and you have some policies that says that my Siemens PLCs are going to be residing on VLAN 300, and up above in the firewall, I have a policy that says I'm only going to allow Modbus to come from VLAN 300. And the same thing for your Schneiders, the same thing for your ABB PLCs. But now what happens when I get to click PLC? Well, there is such a thing as a click PLC, believe it or not. This is not something that I made up. And if you look at the logs and you start looking at the logs on that, it will say click PLC when they get detected. Well, as funny as it might sound, you can take, when you see something that is not there, because you already created all your policies and you created the directional traffic, then you can say, when something is not in accordance to either change control or the policies that I designated, I'm going to quarantine it. Notice that I didn't say block it. I'm going to quarantine it. I'm going to create some level of alert, to the NOC, the SOC, or whatever your central, repository for monitoring is, and say, what do we do with this guy? Keep that in mind, because when they're at 3 o'clock in the morning, when something breaks and the operator, all they have is a click PLC, you don't want to be the one telling them that the plant is going to be down because it didn't go through change control. Have change control, make an exception, and go on. But then you can put it back in operation, and then you can make a decision as to what you do next. Oh yeah, this is part of that FortiDeceptor thing. They'll say, visibility is important to us. Definition. There's a big difference between visualization and visibility. A lot of people confuse them and they kind of transpose the two terms. Visualization is a graphical representation of what you have in your environment. It might be tiered, like you see in this case. It might be done per VLAN, but you see it, or you see in very detail in a topology map of sorts. Visibility is being able to see inside the packet. To me, I always like it to, all right, in a car, you have Google Maps and that's your visualization. It tells you where you go. Will you drive your car based on that map alone? No. To me, visibility is the windshield. You make the decision based on what you see right in front. So it's really important to make a clear definition, because when we go back to those models and we start talking about tiering and segmentation, visibility and visualization, think of it as you want to go to visibility at the lowest level OSI or the highest, depending where you start. So you want to do it at layer 7. We give you that capability. Oh yeah, there's a ton of products that we have. And we're Fortinet, by the way, over 40 products. I believe that we're 55 products nowadays. Anything that has a box around is being adapted to OT. So we have quite a few. I think about a good 2/3 of the entire line is OT. I'll sum it up by saying, if you're going through that period of transformation, digital transformation, modernizing your environment, you're passing data from the lower levels of there's a requirement to create more accurate reporting and speedier reporting. Secure connectivity is really important, and in order for you to reduce the likeliness of having a big disaster on your hands that might actually even translate to somebody getting hurt. Consider segmentation or microsegmentation. If you haven't started it yet, and all you have is a division between IT and OT, hey, that's good. Maybe your business, that's all you require. However, when you start looking at reducing this into more manageable units, it makes your life a lot simpler. It allows you to be more granular. It allows you to be more agile in some instances, because if you have to change your policy, it's better to change policy that will affect 3 or 4 devices than one policy that affects, I don't know, a couple of thousand. It's a lot easier. So yeah, for us, secure, and this is the commercial, right? Secure remote access, that's stuff that we do in addition to segmentation, in addition to visibility. Every single thing that we do in Fortinet is based on our artificial intelligence. We are spending a lot of time and effort in an operational technology, because we do see that the threat to our critical infrastructure in this country, as defined by Homeland Security, not by Carlos Sanchez, it is imminent. The adversary is going again, after these structures. That's what drives me to be here today. Pass that message. We all work in critical infrastructure. I don't care if you work in transportation, manufacturing, energy production, healthcare. We saw what happens in transportation and manufacturing and healthcare, during the pandemic. These are critical infrastructures. And because they're so important, they're the #1 target nowadays. What we've seen in the news and what we continue to see in the news, in reality, that's the tip of the iceberg. More is coming, and more regulation is coming. We're going to be subject to more compliance. And guess what? If you're in gas here, the TSA compliance mandate and all that stuff, it all centers around 2 things: password management and segmentation. That's the bottom line of that. The government was going to continue to examine and take a closer look at how we protect our critical infrastructures. So that if you think TSA was complex, that's the tip of the iceberg, and it will be more to come. And that's all I got for you. Any questions before I hit my coffee? Well, hell. Sherry, how do we get the slide deck? Okay, good deal. Any other questions? They make me come down from my very comfortable. Yeah, let me.
The IO.
Yeah.
So for me, it's getting critical to also do this for IO, right? Not for the RTU, but really for the Profinet and stuff like that, right? All the IO stations. Is this already done? Is it doable? Is it, because then we talk about uptime, right, and safety and stuff like that. How would that work in this technology?
You're looking at how to implement it?
This almost looks like software-defined networking, right? Sort of. It is, right? In your own format. If you apply it to an RTU, is one thing. But if you apply it to the IO stations, to the overloads, to the drives, right?
Sure.
In the field, that's not yet on your PowerPoints there. But I assume
that's where the business is going. That's where the business is going. Now, we do have the capability to go to that level if we want to. However, not everybody that does this wants to go that deep. Some people, like to, rely a little bit too much in whatever the SCADA platform is, whatever the control is. If it's if it's a Rockwell shop, they can plant AX or something like that, Honeywell, and they like to rely on that to have that level of visibility and control. However, none of those systems, protects a physical plant. None of them.
So Ben, they talk about the example of SIP, right?
Mm-hmm.
With SIP, people can go with the right tool, pass the backplane in your IO. Thank you. I don't feel better knowing people can do that, right? So to me, yeah, we have to
control it when it goes out. How do you control the IO?
I don't even know yet how to do it. I just know. We have to start doing something, right?
Yeah. There are ways that you can intercept that. You can do it passively, as a matter of fact. You can look at the controls around sending to the IO and what's going into the IO. So that's what we're doing all that. In fact, if we break down that list of protocols and applications and stuff that we have, if we break it down all the way down, it has about 2,000 different iterations that can be utilized in policies. So it's pretty deep. Anyone? Yes, sir. You're getting the presentation. All right, man, that's fine.
What tool on that slide is something I would use from Fortinet to manage a large quantity of your appliances? Is it FortiManager?
FortiManager, yes.
And is there a limitation in terms of what appliances or how many appliances?
FortiManager is interesting because in theory, when you look at it, it can manage over 25,000 network elements. However, is it practical to have that many on one platform? Probably not. So the recommendation, at least, and I used to be an NIST many years ago, is make it tiered. You know, put an instance, something that is more manageable. In the cases where FortiManager is deployed as a VM, well, then you're dependent on the resiliency and the speed of the hypervisor, the host. In the cases that is just an appliance, and we do sell them as well as, then you can probably partition or create or put some backups. I mean, depending on the operation, the criticality of the operation. Okay. But yeah, the FortiManager is the one, and in fact, this new version has all that Purdue view already. So you can do, whenever you do the configuration and tier everything according to Purdue or 443, because they're pretty damn similar, you can put that, it will show in a topology map on the FortiManager as such.
What version is that?
7.2.
Thank you.
We're done. That's my time. I already dropped the mic, so I can drop it again.